Alright, welcome to another AQA AS Chemistry video. I promised a video quite a long time ago that I would actually do this. This will be one of 3 videos that I'll do relating to periodicity. So related to inorganic chemistry. So inorganic chemistry, AS inorganic chemistry questions. This is the first one, so it'll be about periodicity, and then the next paper will be about paper 2. So the next one will be about group 2, and then the next one will be about group 7. That's it. Yeah. So this is a paper based off of periodicity and all the questions related to periodicity. Yeah, I'm gonna go straight through that now, and yeah, so this is a 47-minute. I've cancelled some questions out because they include some year 2 topics that you're not familiar with. So because this is an A-level paper, I always try to get the A-level paper because that's what you'll be doing in an exam for the people that are doing this. And yeah, because I'm going straight into it. So this is a 47-minute paper. Let's put 47 minutes down. I might go slightly over because I'm trying to explain to you as I go through it. In fact, you know what? I'm going to tell you the questions to do and not to do. So I'll leave a link in the description to this exam paper, but I want you to ignore questions 5B, 5D, 9E. I thought about 9A, but I think I might just go through that one. I haven't really gone through the questions. I've just seen which questions that look like they're year 2. So if I go through a year 2 topic in there, and it clearly is year 2, then don't do it. So yes, and the last C question, or last C and D question. So don't do questions 20, C and D. Apart from that, you should be able to do those. And so do that. And then when you've done the video, once you've done those questions, if you're still confused about how we went through that, I'll kind of go through it right now. And I'll go through the mark scheme as well. So yeah, gonna go straight through that. So 20 minutes. So why did I say 20 minutes? It's 47 minutes, sorry. 41, okay, and go. All right, so which element is classified as a D block element? Go here, D block element. I know it's definitely not these two. And I think strontium, no, strontium isn't. Strontium is definitely not. Yeah, I got confused between another one. Is antimony one or is it molybdenum? No, molybdenum is. So that's that there. Which element periphery has the highest melting point? Silicon. You should know that from, you know, covalent bonding, metallic, molecular solid. Which ion has the largest radius? So not Mg2 plus. Definitely not that one because this will be bigger than that. F minus wouldn't be. I would go for Na plus. Why am I? If that has 16 and you're adding another 2 electrons, I would actually go O2 minus actually. No. I've got my periodic table here, right? So that's what I'm looking at here. And then you add another 2 electrons, right? That's Na plus, so that has lost an electron. And this would be smaller because it's a higher nuclear charge. It would even have a higher, stronger nuclear charge. So no, I'd say O2 minus. And that's how you cancel out an exam. O2 minus. Sorry, I'm trying to try to arrange this over here. Which element has the first ionization energy lower than that of sulfur? Lower than that of sulfur. Ionization energy. Oh, selenium. Selenium is just underneath it. Selenium is, remember, ionization energy is decreased as you go down the group because weaker electrostatic attraction. So selenium. Okay, so this question is about elements period 3 and their compounds. When a piece of sodium is added to 200 centimeters cubed of water in a large beaker, biggest reaction happens. Temperature of the water increases by 25 degrees Celsius. Given an equation for including state symbols. For the reaction of sodium with water. Justify it's dangerous to react with a similar piece of sodium with 10 centimeters cubed of water in a boiling tube. So sodium plus water goes to form. So sodium solid, water liquid goes to form Na sodium hydroxide aqueous plus H2 gas. But as far as I remember, you can't have that because that would be 2, 2, 2, I believe. 2 sodiums, 4 hydrogens, yes. 2 oxygens. Yes, and why is this dangerous? It's quite, the reaction would be quite too vigorous, say explosive. The reaction would be too explosive. The reaction could be explosive. This suggests. And reactant could leave the beaker. So explain in terms of crystal structure and bonding why silicon 4 oxide has a higher melting point than phosphorus 5 oxide. Alright, so I chose this question because technically this is a year 2 topic, but forget the oxide, right? You can actually they have very similar. It's very the thing of this reaction the exact same as that of the year 1 understanding, because silicon has covalent bonding, phosphorus has van der Waals molecular forces, and I know it's their crystal structures, but they're very similar. They are very, very similar. And I'll show you why, because silicon's out. So they're almost this. I think it is nearly the same, really. Between if you forget the oxide part, right? Forget the oxide part, like for example, and just think of silicon and phosphorus, which one would be would have the higher melting point. You still say silicon, and it's literally for the exact same reason, because I say silicon dioxide here. SiO2 for this case has or is a giant covalent structure, a giant, you can say macromolecular, so it's a giant covalent structure with strong covalent intramolecular forces, so with strong covalent, I say covalent bonds, I won't go into depth, say intramolecular unless he's really say, but technically they are intramolecular forces though, really. Covalent covalent bonds. You can just say covalent bonds. SO2 is a giant covalent structure with strong covalent bonds that require more energy to break. My pen really gonna give up on me right now? It is great. Is this one gonna give up on me? Also great. not in a very good mood, guys. England just lost to France. It's not good, guys. Anyway, SiO2 is a giant covalent structure with strong covalent bonds that require more energy to break. I should have used bullet points here. I would have had SiO2 giant covalent structure, strong covalent bonds is 4 marks here. That require more energy to break. Compared to P4O10, which is phosphorus oxide. Again, it's a year 2 topic. They have to know the name of the equation for that. But just it's the same principle. So compared to P4O10, which is a molecular solid, with weaker van der Waals intermolecular forces that require less energy to break. Yes. Alright, so give the formula. Yes, and you see it. I have 4 bullet points for 4 points, and you can just do bullet points in your exam. I know for other exam, maybe for like physics, man, want good English, but literally you can have 4 bullet points or do it in the table as long as you present your 4 points. I think it's the best way to do it in bullet points because it's the easiest way to do it. To show you, it's easier for the examiner to see your points, and it's make sure that you don't waffle. You're just saying the points. They don't want a well-constructed, linguistically, good statement. They just want you to have your 4 points. Give the formula of the hydroxide of an element in period 3 used in medicine. Magnesium hydroxide. You should know this. If you don't know this, then check out my video when I explain this. It's highly insoluble and used as a magnesium milk for indigestion, for neutralizes, acts as an antacid. This is a weak base. Identify the element in period 3 that from sodium to chlorine that has the largest atomic radius. It should be sodium. I'll say sodium just in case they but I didn't say name, but still. Okay. This question is about atomic radius. There's a general trend for increase in ionization energy across period 3. Give one example of an element that deviates from this trend. So I can have either one of the two. I'll pick aluminium. I could pick sulfur as well, but I'll say aluminium. And because aluminium loses an electron from the 3p orbital on the first ionization energy, or the first ionization, I guess. Which is a higher energy orbital compared to 3s. Compared to the 3s orbital, I should say 3s orbital. Yeah, aluminium loses an electron from the 3p orbital, which is the higher energy level compared to the 3s orbital. So I guess more energy required so less energy for ionization, less energy. So say lower ionization energy. than expected. Kind of went on a bit there. Okay, so given equation including state symbols to represent the process that occurs when the third ionization energy of sodium is present. Third ionization energy means that we're creating an ionization with a 3 plus, which means that we start off with a 2 plus. It's obviously going to be in the gaseous. Sorry, it's obviously going to be in the gaseous state. So it's 2 plus in the gaseous state. We're forming a 3 plus. And if you're really confused by all of this, you need to go back and watch my video when I explained. Did I explain ionization energies? I know, I definitely did. Yeah, go back to that video. All right, so see, the graph shows the process successive ionization energies of period 3 elements. Okay. Of element X, or of element X, okay. Identify element X, explain your choice. This is in period 3, right? So period 3, and it's in group 5, so it's phosphorus. Because the jump after they lose the 5th electron goes to the next ionization, next shell. So I'll say this is phosphorus. Because there is, how many marks is this? 3 marks. Phosphorus, so 1 mark for that, and then I'll say next one saying there's a massive increase in the 6th ionization energy. Compared to the 5th. Compared to the general trend between the 5th up till the 5th. Compared to the general trend in increase up until the 5th ionization energy. It says explain the reason why. So that's because you're removing, on the 6th ionization energy, you're removing an electron from the 2nd. This is group 3, so one after that will be group 2. So it would be, there's 3 shells in group 3, it means that there's, there's 3 shells in period 3, which means that the next one will be on the 2nd shell. So you would say after that, so 5th ionization, I say this is, because on the 6th ionization energy, you're removing an electron from from the 2nd shell. Okay, which represents the correct order increase of radius of the ions? Increase. So go from BE to BE2 plus that doesn't work. Li plus then to B, no, that would decrease. BE2 plus, Li plus, yes. F minus, yes, and then O2, yeah, that works. Which of these elements has the highest ionization, which of these elements has the highest melting point? Silicon easily, no problem for me. Sorry, I just got a bit of a runny nose. This graph shows the 2nd ionization energies of some elements in period 3. Okay, draw an X on the graph, which shows the the second ionization energy of silicon. So the second ionization energy it should still be high, but silicon's one of those examples where if you remove, do they know this? It's one of them ones. It's actually between here. Did I explain why? I know it's between here and here. I've forgotten the reason why. This is one example where I forgot the reason why it's between. It's I know it's like roughly. I know it's like roughly here. It's like it's a small increase, right? It's a small. So it's a small decrease. Just dips a little bit here. I forgot the reason why though. I mustn't lie. Identify the element in period 3 from sodium to argon that has the highest second ionization energy, and a given equation including state symbols show the process that occurs when the second ionization energy of this element is measured. And if you are not able to, now you can do that. Okay, so element in period 3 from sodium to argon has highest second ionization energy. Sodium, because you're removing an electron from the second shell. You're removing an electron from a new energy level or a new shell that's closer to the nucleus, because sodium's in group 1. So the process that occurs, second ionization. So you're going from Na plus Na2 plus gas plus electron, always in the gaseous state. Did I say that to make sure to put an electron? Yeah, electron there. Explain why the atomic radius decreases across period 3 from sodium to chlorine. You should know this because these questions, they always say when you say this part. Nuclear charge increases, or say proton number increases. Nuclear charge increases for electrons added to the same energy level, or same energy level, you should say, or say electron shell. Sorry, it's really runny nose, pissing me off now. Alright, identify an element in period 3 from sodium to chlorine that has the highest electronegativity. It would have been in period 3. It would have been argon, because you want the one that has the highest electrostatic force of attraction, or the highest pulling factor from the nucleus. But remember that argon doesn't actually, it's a noble gas, doesn't really react, doesn't really get involved in reactions like that. So it will be chlorine. Chlorine will be the second next one. And usually the halides are the ones that usually are the most electronegative, usually, when it comes to periods. This question is about periodicity. The period 4 elements are and their compounds. Say the meaning of the term periodicity is just repeating patterns in the periodic table. So repeating patterns in the periodic table. Repeating patterns that occur over regular intervals in the periodic table. Identify element in period 4 which has the highest electronegativity value. Bromine. Same period, same trend. Make sure this is actually very important. If they said name, they said name, then you have to actually write bromine. You wouldn't get away with BR because they said name. But here they just said identify, so it doesn't really matter. But be careful. But I've seen people, even myself, I've messed up on things like that. If they say name, you write bromine. But if you just say identify, you can just write bromine or BR. Doesn't matter. Okay, so identify the element in period 4 with the largest atomic radius. The largest atomic radius in period 4, potassium. It has the lowest nuclear charge. And hence weakest electrostatic force of attraction. Between the nucleus and valence shell, and outermost electron or valence shell. Say outer valence / outer shell. Alright, so the equation for the two reactions for arsenic oxide are shown. Okay, name the two properties of arsenic oxide that would describe this ability to react in these two ways. It's reacting with both an acid and a base, so it's both acidic and basic, so I'd say it's amphoteric. Sorry, I know my nose is really runny. Complete the equation, so just okay, so just balancing this, right? HNO ASO ZN H and N. So 2 6 1 1. Yeah, 1 as well. Three, 4, 5. Then 1, 2. No. Yeah, 2. Oxygen is 6, 7. If I make that a 2, that's 6, 7, 8. You know what? I'll come back to this one. I can do it, but it'll take a lot of time. It'll take more time. These are easy questions I see right now, right? These look like easy ones. Let me just do these quiz one quickly and then I'll come back to that one. The diagram shows how a property of period-free elements varies across the period. What is the property? This is melting point. Which element has the highest first ionization energy? First ionization energy. It should be phosphorus. Phosphorus, yeah. Not aluminium, not silicon, not sulfur. Yeah, not sulfur for that reason, because of the pairing, there'll be electron pairing in the 3p orbital, so no. Phosphorus. Which of these period-free elements has the highest melting point? Aluminium. Aluminium. What is the correct order of the melting point in period-free element? This is SA. You just S8 P4 Cl2 argon, right? in that order, actually. That's right, actually, even in that order. No. Sulfur is the highest. The things I do for this channel, man. Alright, which is the correct classification of the element? Yttrium. Yttrium is very rare. Oh, D block, I can see here. D block. Well, not D block, Europe. Which of the following is the correct statement about the trending atomic radius across period 3 of the periodic table? Radius decreases because nuclear charge increases, yes. Which element in F block? It's in the F block of the plutonium. I don't even need to look at that. The radioactive one's always F blocks. Alright, so which element are shown in the increasing order in the same increasing order of the stated property? Atomic rate increase. That was increase. That'll get smaller. First ionization. It would increase, it decreases. But these two increase, but then electron. These two increase, but then aluminum decreases. Electronegativity at a certain amount, but this one definitely. Not more definitely. Alright, which is. My running nose is really annoying me. Sorry, I should have got tissue. Which of these elements has the highest second ionization energy? Sodium. I'm already going to get proven wrong. Sodium. Yeah, it should be sodium anyway. Group 1. Explain why atomic radius of elements decreases because period 3. We've done this one, so nuclear charge increases. For electrons added to the same valence shell, so electrostatic attraction between the nucleus and outermost electron and outer shell increase. 16 minutes left to answer this. 16 minutes left spare to just do this one question. Explain why the melting point, and this and the other one I kind of went over.
Counting down.
Thanks, Siri. Appreciate that one. I don't know why I said that, but anyway, explain why the melting point of SA is greater than phosphorus P4 because S8 is a larger molecule with a larger MR. SA is a larger molecule with a larger MR. By the way, I always say what I'm writing down just in case people can't see that. So if I accidentally is in shot, because I can't really see what's in shot or not, I say it out loud. So exactly what I'm saying when I'm writing down is the exact same things I'm writing down. So I always say what I'm writing down in case you can't see what I'm writing down. Anyway, SA is a larger molecule with a larger MR than P4. So S8, not Samsung, has a larger, or has stronger van der Waals intermolecular forces. Than S8, then P4, so more energy is required to break all the bonds. Okay, so we go back to that one question that we were trying to... Wait. I'm trying to get more space here, because I can never... Let me make more space here for a second. Because it's actually such a hard thing to do, getting all this space here. What was I doing? Oh yeah, go back to usually I go straight to the start, right? And I go all the way to see where I went wrong. So if I did any mistakes, I usually do. I just go straight up. Don't do that. Go straight to the question that you know you haven't done, and then you go and look after what we haven't done yet. I know I haven't done this question yet, so yeah. So AS is hit. So it has 6 on this, 2, 6, 7, 8. Oxygen is still 7. This needs to be 2. 2, 7. If I make that 2, right? I need 8 hydrogens. Okay, so if I make that 8, right? 8. Never write it fully down yet. Always have an idea of what you want to do first. So then 8 here. Nitrogen, also 8. Yeah, nitrogen is also an 8. How much time have I got left to this question? See, I have plenty of time to go do this question now. 24, right? So then 1, 2, 1, 24, 8, 8. How many is this? So 24. If I make this what, 6? That's 6 there. They don't even have too much. Unless if I make this a 6, right? Unless I make this a 5. There is no real actual formula for doing this. You just have to go and chop and change. I like to. There's actually a way of doing this, but the other answer is just kind of just going and seeing what you can do here. If I make that a 5, right, and then I have now 5 ZNs. Put 5 here, right? 5 ZNs. It'd be 10 nitrogens. 10 nitrogens. 30 oxygens. 31 oxygens, really. Then this needs to be 6 because you haven't. You can't get now. I say 6, right? And if that's a 6, then this has got to be a 12 then. Right, if I have 6 of that, that has to be 6. So this is a tricky one. I'm not gonna. It looks like it's just an easy one, but I say this isn't as easy as it looks. So 6 ZN right here. 12 hydrogens. nitrogens is equal to, oh, that's 12 as well. Thirty-six that, and then AS, still 2 of that. No, but then you have 36, 37, 38, 39. 39 here. 2 oxygens are what? 36, 39. No, 36. It's 37. No, 37. What am I talking about? 37. If I make this 3, because then it'll be 39. I'm honestly playing around with this way too much now. But then how many hydrogens do I have now? That's 6. 12. 12, yes, 12. And then nitrogens is nitrogen. Actually, no. No, it's 2. So that's 12, actually. Yeah. 2, 39, 6, 12, 12. This is a monster. I would, yeah, but you can do it. This is just how you do it. It is a bit of a monster, but, you know, you can do it. You can do it. And you just have to see, if you could just multiply, you can see it. So, 7 minutes on the clock right now, not at the time. 7 minutes of injury time. Let's see if we can just go and make sure that the game is closed off. I ain't trying to go to extra time, unlike England couldn't do. Which element is classified as a D block element? Happy with that. Highest melting point, happy with that. This one here, am I happy with this one? I am happy with it. Na plus would be here, I'm happy with that. F minus. F minus. O2 minus would be bigger than that. No, I'm happy with that. O2 minus would be bigger than that. But really and truly, I did this question, what, 7 minutes and 7 minutes 38. What was it? I think it was 7 minutes 38 and I finished this, right? 07:38. Okay. Now I'm just going over it really. But I finished that 07:38. I'll let the timer keep going because we'll have time to go there, but yeah. Giant convey structure, current bonds. Answers all aspects of the questions to explain. Make sure to underline. I haven't done these in a long time, so bear with me, just bear with me, right? Magnesium hydroxide, sodium. Yes. Do I agree with this? Increasing, so it should be going this way, right? So BET plus yes, Li plus yes, F minus yes, OT minus yes. Do you have to worry about the ions really? Because remember, all you're looking for is which group they're in. Because remember, F minus and OT minus, right? Unless they're going, unless your OT minus would just mean that it has 8 electrons, and this has also 8 electrons, but they're all in the same. They're all in the same energy level. They're all in this. The electrons are all being added to the same energy level here. So you don't have to worry about that. Unless this was like F2 minus, and then I'd say this is probably bigger because it's adding another energy level. But yeah, same energy level. But nuclear charge is higher on O2 minus. Sorry, is it? No, O2 minus has a lower nuclear charge, so it's a weaker electrostatic force of attraction. So it's pulls in less, so the radius is larger. Yes. Highest melting point, silicon, the silicon's giant covalent structure. Answer with aspects of that. Make that a bit more. This is what you do after the exam. You just literally just go through it. If you have time like this, like I did, like you should be able to do more than 1 mark per minute in chemistry generally, at least for year 1 content. And sometimes with year 2 content, I find year 2 content easier than year 1. Yes, this is the only thing that kind of works, but I think I can actually fine. So lowest nuclear charge. Maybe make this K a little bit more. Amphoteric. This is definitely melting point. I just went through that. I just went through this, obviously. Yes, because the electron is between this and this. But remember, you think this one, but it's because of that paired electron shells in sulfur. That's why you would have electron repulsion there, and phosphorus actually would have a higher first ionization energy. Aluminium out of those ones there. This one I already went through. Strong molecular solid, strong molecular solid. So these are both solids. Gas, gas. At least this is a more. At least this would be if this was solid, it would have a stronger melting, a higher melting point than that. At least I can say that for certain. D block. Across, yeah, that's fine. Yes. Yes. Nuclear charge increases for electrons as the same valence shell, so electrostatic attraction between the nucleus and outer electron shell increases. And this one fine, yep. And fine, let me go get the mark scheme now. There we go. Okay. Okay. I just want to end this one. My nose is way too runny. But where is it gone? Where's my red pen gone? Oh, it's it. Yes, it's here. All right, cool. So I'm gonna just tell you if it's correct or not. BBD. D. And then 5A was 2Na, 2H2O liquid, 2NaOH aqueous, H2. So temperature will go up or reactions can shoot out the tube. Allow the mixture could explode or gas. So you could say, I said the reaction could be explosive and reaction could leave the beaker. I didn't say shoot out the tube, but I definitely mentioned the word explosive, so I guess they'd allow that. Skipped B. SiO2 is a macromolecular or giant covalent structure. Giant covalent structure, that's MARCSI. And then strong covalent bonds, so strong covalent bonds, another mark there. P410 is a molecular solid here. Weak van der Waals intermolecular forces between the thing is, they say between molecules, and that's underlined. Anything that's underlined, you have to say it. But the thing is, intermolecular force. The word intermolecular means between molecules. So if you're saying weaker Van Waals intermolecular forces, that is pretty much the same thing as saying between molecules. Double check with your teacher and just say between molecules just to be certain. But from my experience, saying weak Van Waals intermolecular forces is the same as saying weak Van Waals forces, also it's the same as saying weak Van Waals forces between molecules. But go with the mark scheme. AQA very stingy, but I say is weak Van Waals. You're saying specifically intermolecular forces, but in this case, not going to allow it. But check with your teacher at least. Check with your teacher. I'm stingy, so I haven't got exams anymore. But actually, you know what? No, I'll be stingy. 3 out of 4. I'm not saying. It's underlined, so I have to say it, I guess. The next one after that is we skipped D. I know how to do D, but not like that. Don't twist me. But you guys don't know about that one still. Magnesium hydroxide, sodium. They said identify, so you have to say that you can say either sodium or Na. Next one is aluminium. You could have said aluminium or sulfur, as I said before. You can pick either one, but aluminium, the outer electron is from the free, is removed from the free. You don't have to say actually outer is in brackets, so you just say electron in 3p orbital subshell. It's a higher energy than orbital compared to. It's a higher energy orbital compared to the 3s orbital. And that's 3 on 3 marks there. And then B is just saying this Na2 plus the third ionization energy of sodium. That's not a problem. After that, did I end this? Yeah. After that, what's it? Phosphorus. Large jump, massive jump in ionization energy for the 6th ionization energy. This is when an electron moved from the second principle or second energy level. So 6th ionization, your second shell. Data shell. Yes, from the second shell or lower shell. 3 marks. Better to say from a second energy level, but yeah. Basically, second energy level, from a lower energy level, from a lower shell, so on and so on. Question 7 is C. 8 is C. 8 between 15 80. I was way higher than I thought it was. I thought it's here, but it's actually more like here. It's more like there. So I guess that's wrong too. I forgot the reasoning why for that question anyway. I know there's just a small dip. 9b is sodium. And the second ionization energy for sodium, no problem for me. The number of protons in C, nuclear charge increases is 1 mark. Electrons added to the same shell or same energy level. Yeah. Next one is chlorine. The next one, I was tempted to make you guys do that one, but I knew some people, it's a year 2 one, so I guess I shouldn't have used it, but we move on now. Question 10. Periodicity is repeating patterns. Just saying repeating patterns is enough for question 10. So 1 marker, repeating patterns. Yeah. Next one is bromine or Br. Next one's potassium. Next one after that is, saying why it's potassium because it has the smallest nuclear charge or lowest nuclear charge. So lowest nuclear charge, right? And it's the same Ah, I forgot to say for the same shell. That's my problem now. Lowest nuclear charge, I said 4 electrons on the same shell. I should have said 4. That's a typical mistake for me. That's an easy one. I should have got 4 electrons on the same shell. Make sure that you're not losing marks like me on the easy questions like that on the same shell. Right. The next one after that is saying amphoteric, which is the one I think it is, and it's amphoteric. Next after that, AS2O3 plus 6Zn plus 12HNO3 plus 2AS H3 plus 6 sorry, my nose is really blocked up right now. 6ZnNO3 2 plus 3H2O. Yeah, and that's it. Oh, I should have showed you here. That. No problem. Melting point is D. 12 is B. 13 is A. 14 is C. 15 is C. 16 is B. 17 is B. No, sorry, 17 is D. Sorry, 17 is D. 18 is D. 19 is A. 20 is nuclear charge increases. Attraction between the nucleus and electrons increases. So electrostatic attraction between nucleus and outer shell. And outer electron shell increases. Alright, so S8 is the next one saying S8 molecules are bigger than P4 molecules. Yes, and all saying that the MR then S8 has a larger MR than P4, so that's just one mark there. And S8 has stronger van der Waals intermolecular forces between molecules compared to sulfur. Sorry, S8 has stronger. S8 has stronger van der Waals intermolecular forces than P4, so more energy is required to break all the bonds. So I said, so that's what I said. So that therefore, van der Waals or dispersion on force between molecules is stronger in sulfur, right? And how many I got? How many? Let me just count how many got wrong, because that is where I made the mistake. One lost, one mark there, another mark there. Sure, I think I lost 3 marks in total. Yes. 44. So 44 out of 47. Not bad. Alright, the video's done now. Hopefully you found this useful.